Again, we want to be careful when we read instructions exactly what is asked for. This one starts off by saying determine algebraically. So that means we want to solve for this using algebra. Algebraically, how do we find inverses? That's where we switch the x and the y and solve for y. So they want to find out whether in part I is y equals 3x minus 6 and y equals 6 x minus 6 all over 3, are those inverses? So if I wanted to check that algebraically, I could take that first equation, y equals 3x minus 6, and I could find the inverse algebraically by switching, switching x and y. So there we go. X equals 3y minus 6. How do I solve for y? I'm going to move the 6 over. I'm going to get x plus 6 equals 3y. Divide by 3. And now that is the equation of the inverse. Does it match the other one that they gave us? No. So they are not inverses. Because this one has a plus sign in between the x and the 6, and the one that they suggested had a minus sign in between the x and the 6. In the second one, notice that they have restricted the domain. They give us an equation of a parabola, y equals negative x squared plus 3, and they restricted the domain to x being greater than or equal to 0. So how does that affect us? Because when we switch the x and the y, we're going to get x equals negative y squared plus 3. In this case, with the negative with the y squared, I'm going to move the y squared to the left side. Can you see that that would make that positive? And I'm going to move the x to the right side by subtracting x on both sides. Is everybody okay with that step there? I did two things. I moved the y squared to the left-hand side of the equation by adding it to both sides, and I moved the x to the right-hand side. I did that so that y squared was by itself, and now I can square root both sides. But now we have a little bit of a dilemma. Because the domain is restricted, chances are, well, I will tell you that your inverse is only going to be one of these. But how do we decide which one? If the x values are greater than 0, remember the number one thing with inverses is you switch x and y. So if in the original, and I'll write it in red, if the original has x is bigger than or equal to 0, then on the inverse you're going to have, if I switch x and y, then y has to be bigger than or equal to 0. Because that switching x and y happens in all areas. So if we can switch x and y algebraically, we can switch x and y with domain and range and all sorts of things. So if the domain was x is bigger than 0 on the original one, that's telling us that the range of our inverse has to be y is greater than or equal to 0. And if y is greater than or equal to 0, which of these equations will it be? It will have to be the positive one, not the negative one. Because a square root is always positive, even if there's negative stuff happening inside. And so we would need the positive one to match. Now I got y equals the square root of negative x plus 3. Does that match with what they gave us? Yes. I mean, they wrote 3 minus x, and we have negative x plus 3, but we need to be able to recognize that when you add and subtract things, the order doesn't matter. And so this is the same as 3 minus x. So we could say, yes, they are inverses. In part B, it says, could you verify this graphically? So what we're going to do in part B is we are going to graph the original one each time in red, and we're going to graph the image in green that they gave us. So I'm going to graph one in red and one in green. Y equals 3x minus 6. That's an easy one to graph because it's in y equals mx plus b form. So from before, you know that you go, y-intercept would be at minus 6. 3 is the slope, so we go up 3 over 1, up 3 over 1. This is the equation of y equals 3x minus 6. And I'll label it now. The green graph that we were asked to write was, or to graph, is y equals x minus 6 all over 3. Some things I want you to start to recognize. First of all, when you look at the x, do you see that you have an x to the 1? This is going to be a line as well. But it's not in y equals mx plus b form because I'm all dividing the whole thing by 3. If I divide each individual thing by 3, x divided by 3, can you see that that's the same as 1/3 x? And negative 6 divided by 3 would be a minus 2. So a little bit of algebraic manipulation, and I change this to y equals mx plus b form. If I have it this way, I now know negative 2 is the y-intercept. A slope of 1/3 means a rise of 1, a run of 3, and there's my graph. How can I tell graphically that these are not inverses of each other? It would have to be a reflection over that line, right? Couple of things that happen when you reflect over that line. If it was a true inverse, the point where it intersects the line y equals x would not have changed. But in this case, the green one does not go through that point. If you think about reflecting this over the line y equals x, it would have looked like, here I'll draw it in purple, this would have been the proper one. Can you see that that is a complete straight reflection over? This point stays the same. Everything else went straight over that line. That purple one would have been the proper equation. And we saw that algebraically because we got a different answer when we switched x and y. So this green graph, I'll write the equation that way. And we can see graphically that they're not inverses of each other. For the second one, again, we're going to do it the original graph in red. The original graph was negative x squared plus 3. Negative x squared would flip our parabola upside down, and then plus 3 would shift it up 3. You would have, this is your vertex at 0, 3. And because the domain is restricted to be x bigger than or equal to 0, we only would have this half. If we were to graph this, oh, do people have problems graphing y equals square root of 3 minus x? Why? Well, for one, the 3 is written before the x. You can switch it around, but if it's written in the wrong order, just because it's what you're not used to seeing it that way, you make mistakes. So I'm going to first change it to this. What will that negative do? It's going to be what kind of reflection? Horizontal or vertical? Horizontal reflection, right? Because it's inside. And what's the 3 going to do? 3 to the left. So everybody says 3 to the left. And what did you guys forget again? You forgot that special note. One year I even had a student, she said, I'm gonna forget that special note, like you said. Whenever you have a horizontal reflection or stretch and a horizontal translation, you have to write it in factored form. So you have to first factor that negative out and get x minus 3, and it will shift it 3 to the right, not 3 to the left. So this student said, you know what? Whenever you give us one of those special notes, I'm going to set an alarm reminder in my phone for 10 p.m. every night. And sure enough, every night her phone would go, bling, remember to factor out, blah, blah, blah. And she would have that note, and it would, so that she said, well, by the end of the year, then I'm going to see it 100 times before the exam, and I'm not going to forget. I'm going to be annoyed every night at 10 o'clock because I'm going to get a reminder about math, but maybe I won't forget this. I don't know how many things she added on during the year, so that like from 10 to 11 it was non-stop reminders. I'm not sure. But maybe you want to do something like that, because again, notice that every time I ask you, you've forgotten again. And it's so hard, especially when it's just a negative. So now that we have the factored form, this is a square root graph. It's been reflected horizontally over top of the y-axis and then shifted 3 to the right. So what would that do? You would have this point here, and it would look like that. That is a square root graph flipped over the y-axis and then moved 3 to the right. If we look at this graphically, if we think about the line y equals x, you can see that the red graph and the green graph are reflections of each other over top of that line. And the one point on that line stayed the same. So that's how we can see graphically that one is a reflection of the other. The hard part in this one was graphing the green graph because we had to remember that special note. Okay, questions for homework 7, 8, 11, and 13. 11 and 13 are thinking questions. So I would like you to read them first and think about them. In the last 5 minutes, we'll talk a little bit about 11 and 13. If you want to attempt them and see if you can figure them out before we talk about them, that'd be great.